all very much for being here today. I'm very excited to talk about our new clarifying technology, Millad ClearX 9000. For those of you who don't know who we are a multinational material science company. We span over 70 different locations throughout 15 different countries. We have over 7,000 associates worldwide. And the thing that I really value about Milliken deeply is the fact that we are an innovative company. And I think one of the things that speaks to that innovation is the fact that we have over 11,000 products that span almost every single different market sector that you would touch in your everyday life. Everything from floors to clothing, computers, aircraft, automobile, agriculture, plastics, different chemicals. We really do a dedicated approach to innovating on new products into these different market segments to meet customers' needs and to meet real-world challenges. We are also a highly ethical company. It's something that's very near and dear to who we are, and it's something that really guides what we do, and from the innovation side, from our manufacturing side, from just managing people. We try to be as ethical as possible, and I think demonstrative of that is the fact that we are a 19-time honoree of the world's most ethical company, dedicated by Ethisphere. We also are one of the first 50 companies to actually have a verified net zero target by the SBTi, and we're also among the top 2% of companies globally with an EcoVadis Gold status. So again, ethics and doing what's right is really what's core to us, and it's really what fuels our mission statement, which is striving to make a positive impact for generations to come. And on top of that, what's really, I think, pertinent and important for this kind of audience is our approach to handling the sustainability story around plastics. We're at a plastic show, right? And as we look at what the future holds for plastics, being very innovative and dedicating solutions to solve some of the real world challenges when it comes to meeting some of the sustainability criteria for plastics is what we do. We're very involved throughout the entire value chain to understand what are the unmet needs from the market and how do we as a material science company and an additive supplier be more than just that. We want to supply solutions to the market to solve many of these different challenges, whether it's developing a monomaterial solution that's more suitable for post-consumer recycle, but also how do we enhance PCR content so that our customers can actually utilize more of it in a broader array of applications. And so when we talk about things like upcycling recycled content, it's very important for us to be able to modify those polymers to allow customers to use them in a broader array of applications. We really are dedicated to understanding what these needs are and coming up with solutions that allow us to help our customers solve many of these problems. But today, I'm going to talk about our Millad ClearX 9000. And as I do that, first I want to take a step back in time, right? We are in this industry for over 40 years. We are a leading clarifier provider in this space, and we consider ourselves a leader in the clarified polypropylene space for over 40 years. What has led to that is the fact that for every step along the journey over this 40 years, with each generation from the first generation to today of our fourth generation, which is known as Millad NX8000, we have really taken a very dedicated approach to understanding what are the needs of the market, the unmet needs of each of these clarifiers, and continuing to innovate on each generation so that the next generation continues to solve more and more solutions for this space. And while the NX8000 today is the market leading clarifier, it's the fourth generation, it's the market leader, and it does a lot of great things, but we're not satisfied with just staying there. We want to continue to innovate into the future. And I feel like as one who's been involved in this process for a while now, I feel like this fifth generation product checks a lot of the boxes that many of the unmet needs of the previous generations still have. And how do we get there? How do we understand what those needs are? Well, it really comes down to you, our customers, and understanding what you tell us you need, right? What do you see in the market? And it comes to that voice of customer work to understand what those unmet needs are, what the market gaps are of the current day technologies. So we did a very dedicated approach to understanding what those unmet needs were. We consolidated a list based on what we heard. And this list that's here, it's certainly not exhaustive. but it's what really rose to the top. Our customers were very clear with us about certain things. They wanted a higher level of clarity as the standard in the market, but they wanted to do so with a more efficacious product. So hitting high levels of clarity, but not needing a lot of material to accomplish that goal. Also, taking our chemistry and creating a more stable chemistry. And I'll talk more on these as I go through. But when I talk about stability, chemical stability, things like migration and bloom come to the top of mind for many of our customers. And last but not least is the post-consumer recycle content of clarified polypropylene. What we heard from our customers is, hey, there's a need out there for clarified polypropylene in PCR, and we don't want additives that create a negative effect in that space, right? We want something that is broadly capable of being used, and we don't want a new technology that disrupts that. And so we were able to take all of these needs and really funnel them into our R&D community. And our R&D community came up with through a lot of years and a lot of work on understanding how do we check these boxes so that we create a product that our customers will say, you know what, you heard what we need and you solved those problems. This line here represents kind of the haze continuum that you would see in the market. The majority of the market operates in this space around 2,000 parts per million, which we would call as enhanced quality. It's above that which the previous generations in standard polypropylene can get. It's a great loading. It solves many of the market's needs today. But what we found over time is that customers wanted more, and they started adding more. They get to this space where they add 3,000 parts per million, which we would call kind of a differentiated clarity space. And then they even continued all the way up to 4,000 parts per million, which we would consider the ultimate clarity space. Now, these spaces of 3,000, 4,000 parts per million, these are very important for our customers because what they want to do is replace other polymers out there. They want to improve the quality of their product in such a way that allows them to go out and maybe convert polystyrene or PET or PVC to polypropylene and grow the size of polypropylene. However, what we heard from our customers is, listen, we want this space out here to be our standard, but we don't want to add all of that additive in order to achieve it. And now what we find with Millad ClearX 9000 is that we're actually able to achieve that differentiated clarity or ultimate clarity space with just 400 parts per million. So at over 5 to 10 times less material, we're actually able to get a standard of clarity that's equivalent to that of 3,000 or 4,000 parts per million of NX8000 today. Now, the reason this bar is so broad here is because in certain thicknesses, so in kind of thinner parts, you get that ultimate clarity space. And a little bit thicker parts, you get kind of that differentiated clarity space. And here's just some data to dive into that. So what we were able to do was to take customers' resins and actually evaluate them with ClearX 9000. And you can see here we have everything from 2 melt flow all the way up to 60 melt flow. And then whether you're in the 0.76 millimeter or 1.27 millimeter space, what we found was that this held true. We were able to achieve at 400 parts per million of ClearX 9000, we were able to achieve the performance of either NX8000 at 4,000 ppm or NX8000 at 3,000 ppm. Now, the reason why these thicknesses are here, when we did a market study, we found that the majority of the market that's in clarified polypropylene falls into this spectrum. Obviously, there are some spaces that are thicker, there are some spaces that are thinner, but this is the most common kind of framework that we operate off of based on what the market need is. And so we're just really excited about the fact that no matter what melt flow we're at, what we find is that we can achieve these high levels of clarity at such a low loading. Now, haze values are only one part of the overall aesthetic of a part. What I actually had the opportunity of doing is taking these stacked parts around the world and understanding from our customers, which one do you prefer? And so on the left here, you have NX8000 at 2,000 parts per million. On the right here, you have NX8000 at 4,000 parts per million. And in the middle, we have the Millad ClearX 9000. And you can see here, the haze value of this middle one and the NX8000 of 4,000, they're basically the same number. However, what we found is that almost unanimously, whenever our customers, we stack these up in front of our customers, they chose the Millad ClearX 9000. It just provides a better overall aesthetic. And whenever you see a part, it speaks a lot more than what just a haze value will bring. So not only do we get high levels of clarity at very low loading, we also get a very advanced aesthetic to the part. And this is, thank you, Bhavesh. This is a great example in what I would consider a fairly thick part, multivariable part. It's just overall a very good quality looking product whenever you actually form the part.
From NX9?
This is the ClearX 9000, yes. And now these parts are thinner than this one.
Is the closing level?
I'm sorry?
What is the closing level?
This is 400 parts per million. And this is just another example of just a one with a color in it as well. Again, just continuing to deliver a high level of clarity even in colored parts.
Do you have any data on higher thickness?
We do. We could share that with you. We have all the way up to 2-3 millimeters.
Yeah, data for breakage. See, I include this America. What would be our breakage performance?
With your breakage?
Breakage.
Yeah. So the physical properties, what we found compared to NX8000, they're very similar. There's no, whether it's shrinkage, whether it's flexural modulus, impact properties, it's all very similar.
No difference.
No, not between NX8000 and ClearX, no. And again, speaking to the efficaciousness, one of the things that we've heard very loud and clear from our customers is we don't want our manufacturing process to have to undergo more work, right? We want to make things easier for operators. We want to use less warehouse space, and we want to pay less for freight. And we think that by reducing the overall need by at least 80% of what your additive need is, that we check those boxes. Obviously, using less material in the plant means your operators are loading less bags. They're having less issues in feeding. They're having less warehouse space that they're having to move things in and out of. And then overall, right, what we believe is that shipping less material saves in CO2. It also saves in cost of freight. So pivoting a bit to that second point of stability. This first slide here is on if you take a plaque of NX8000 and a plaque of ClearX 9000 in the same base resin, we actually exposed this to 110 degrees at 8 hours. And you can see based on the haze performance over that time frame, the ClearX 9000 had a very stable performance in this high heat application space compared to the previous generation. We also saw this with previous generations and completely outperformed those as well. Now, what does that mean? How is that relevant? What we believe is that as customers look at high heat applications, whether in the medical space, food application space, where the parts may undergo a lot of heat in a short period of time for treatment, secondary treatment, or let's say a customer stacks their totes in a warehouse that's in a warehouse for a long period of time that's exposed to high heat, having less bloom occur in that part is very important from a customer's perspective to ensure that they view that as a high quality product. But then also expanding the spaces that you can use that resin in by having a more chemically stable product. Another example of this is through migration. If you take this data here, which this is based on our FDA filing, this is NX8000 at 5,000 parts per million and ClearX 9000 at 800 parts per million. Now, when you compare them and you normalize the data to NX8000, which might I say is NX8000 is used in medical applications, food applications. It's a very good performing product when it comes to migration. However, the ClearX 9000, thanks to its efficaciousness and chemical stability of the chemistry, have over a 17 times reduction in total migration. Now, this migration is in olive oil, which is what we would consider one of the harshest food simulants that there is. So being able to demonstrate this level of performance in even the harshest of environments is important for us to demonstrate to our customers how chemically stable this product is. And we have a very broad conditions of use, A through J, for human milk and infant formula as well. Most customers, what I see is the FDA condition of use J is something that's been trending as far as conversations go when it comes to wanting a broader space to play in. and really speaks to the overall chemical stability as well, because it says that there are no limitations to what this chemistry can achieve. So the last point, right, we talked about was on clarified polypropylene in the recycle space. And when I think of that, I think of compatibility. If you think of a recycler or a consumer company that's using post-consumer recycle, they may be going out and resourcing different supplies of recycled content. They don't want to have to worry if the chemistries in that recycled content are going to cause problems to the overall quality of the product. Now, what you see here in this graph is the fourth generation with the third generation. When we look at the fourth generation with the third generation, as you blend those together, you get a very adverse effect on the overall haze. You see a very sharp degradation of the haze performance as those products are blended together. However, what we found with the fifth generation and the fourth generation is that you don't see that same type of adverse effect. So what does that mean? That means that as ClearX 9000 comes into the market and customers are resourcing different resins that they may be using for PCR, they don't have to worry about blending these products together and getting an adverse effect in their plant. It also means that as customers are utilizing different clarifiers to make different resins on their grade wheel, they don't have to worry about a little bit of carryover of one clarifier to the other, because one, they're a drop-in replacement when it comes to physical properties like you asked, but also the haze performance isn't going to see a sharp degradation in performance. So we believe that all of those things really contribute to the fact that, one, it's a very efficacious clarifier to achieve a high level of performance, and it helps in operations from an efficacious standpoint. Two, it's a very chemically stable product. And three, it's a very chemically compatible product so that you can use it and not have to worry about all the adverse effects that come along with different products getting blended together. So that's really why we believe that Millad ClearX 9000 is the clear choice for polypropylene. Thank you all for your time today.